I think you can, yeah.
Okay.
Please go ahead.
Hello, everyone, again. My name is Victoria. I'd like to talk about the Baikal-GVD telescope follow-up analysis of the IceCube neutrino alerts. Baikal Gigaton volume detector has monitored online alerts from IceCube since August 2020 year. And the goal of this work is the search for correlation in the direction and time of the signal in IceCube notifications with events reconstructed from Baikal-GVD data for two modes, muon and cascade. This presentation is based on three main points. First of all, general information. Secondly, the scheme of data transmission and processing in the follow-up regime. And the third, the results of the search of correlations between GVD IceCube between 2020 and 2022 years by cascade mode. Baikal Gigaton volume detector is the biggest neutrino telescope in the Northern Hemisphere. At the moment, it consists of 10 clusters and approximately 3,000 optical models. One optical model looks like this glass sphere. This number is if we take into consideration our experimental strings. Baikal Gigaton volume detector interacts with the other neutrino telescope Antares, KM3net, and of course IceCube, and this work about this interaction. This slide is about two modes of neutrino reconstruction. You probably know about them. They are cascade and muon track modes. We can reconstruct neutrino from neutrino interaction through charge current by cascades and through cascades and through track or cascade modes, and through cascade mode if we talk about neutral current interaction. Muon track in Baikal Gigaton volume detector looks like this interaction you can see here, and cascade interaction you can see in this picture. These two pictures are illustrated angular resolutions for cascades, this picture, and for muon track modes. Here is median angular resolution for single cluster track events, independent on energy and on time accuracy. So you can see from these pictures that track angular resolution is median value is less than one degree. Also, I would like to point out that our online selection of track-like events cuts off events with the net angle less than 120 degrees. As I said, this picture is about cascades. From this picture, you can see that median angle resolution for cascade reconstruction is around 4.5 degrees. So it's better to see at tracks, of course, but at the moment, we pay attention on cascades because of this reason, and also because we still work on muon track reconstruction. So let's move on how GVD works in follow-up regime. Let's imagine that some important event was in galactic, and this event was observed by IceCube Neutrino Observatory. It usually sends the message about important events to a gamma ray circular network. Baikal Gigaton volume detector can get this message. At the same time, it works in its usual mode. It gets information from interactions in deep water. After these data go to shore station, data acquisition system, where online analysis where is online analysis. After that, data go to computer center in Dubna storage. Data also are processed, and we can we can get information through two types of analysis: offline analysis and online analysis. In online analysis, we can get information only about the most important Baikal-GVD events, and the information about other events we can get through offline analysis. Due to these kinds of analysis, we can we can have follow-up analysis in the next time windows, plus minus 500 seconds, plus minus 12 hours, and plus minus 24 hours. So time delays for follow-up analysis is approximately 3 minutes for online analysis, and it's around 24 hours for offline analysis. So since 2020 year, 57 IceCube alerts, we call alerts notifications about signals. They were tracked using GSN. They were all were muon tracks, upgoing muons with energy more than 100 dB. Here is daily tracks of IceCube events 2021 in horizontal coordinates for Baikal-GVD. These cross signs are start points of these events. As you can see from this picture, for the most of the IceCube alerts, incoming directions are downgoing relative to Baikal-GVD horizon. So they almost all have zenith angle less than 90 degrees. Also, I would like to emphasize that the search with GVD events is carried out in a cone 5 degree or 10 degree. Here is just the example of the follow-up analysis for single cluster cascades, and that one went on 14 October, IceCube event. First of all, here is a number of GVD cascade-like events with the weight equals to 1 divided by PSI in psi less than 5 degrees. Here is, for example, in a time window plus minus 30 days from the alert time. And as you can see here, we can see the coincidence between GVD cascade events and between this IceCube event. Secondly, we can get our zenith angle values in the time window plus minus 12 hour from alert time. And of course, we usually do our background analysis. This picture is illustrated a number of cascade events passing cuts in psi less than 5 degrees for 2020 years. All events passed cuts there. Red points are data, and blue line is background there, just to compare data and background for illustration. Of course, we before all calculations, we have effective area values for each neutrino flavor for energy diapason from 1 GeV to 10 BV for a single cluster for spectrum E-2. So as a result, a number of observing coincidences in this time window for this event was just one. A number of background events was 0.44. So p-value using these two values is 0.36. A limit on expected number of neutrino events was 4.36. Exposition using this effective area was 1,787, this value. And in conclusion, a limit on the neutrino fluence was this number. 2.44 GeV divided by square centimeter. So the results of follow-up analysis by single cluster cascade mode 2020, 2021, 2020, yeah. In the absence of significant excess above the background in plus minus 12 hours, upper limits on the neutrino fluence for spectrum E-2 were calculated. They are between 1 and 2.5 GeV divided by square centimeter. For 2021 year, we applied the next cut condition for cascade events. Energy should be more than 40 TeV. And for 2021 year, we found 5 coincidences with energy value of cascade of more than 40 TeV. 2 of them passed our offline selection. I would like to stop just a bit on this event. This event was the 8th of December. On this data, IceCube bronze event was observed with IceCube with energy 171 TeV in the vicinity of the bright blazar PKS 0735 plus 17. Secondly, active state of this blazar was observed in optical, gamma rays, X-rays, and radio diapasons. Thirdly, Baikal gigaton volume detector observed downward going cascade-like event with energy 43 TeV. For 4 hours after this IceCube event, in a cone 5.3 from these IceCube events, and in a cone less than 5 degrees from the blazar. And we sent astronomical telegram with this number. Also, Baksan Neutrino Observatory and KM3Net, they sent astronomical telegrams too. The per-trial Baikal-GVD p-value for this event was 2.85 sigma. But we should take into consideration that trial factor for this event was 40. Also, here are upper limits for neutrino fluence for IceCube events 2020-2022. They are all 4 energies in this diapason with spectrum E-2 if we assume equal fluence in all flavors. So you can see the diapason. These upper limits were published in these works. Taking everything into consideration, we can conclude that Baikal-GVD tracks notifications about high energy neutrino events IceCube in online mode. The results of the search of coincidences between track-like events IceCube and cascade-like events of Baikal-GVD for 2020-2022 years were illustrated. For single cluster cascade mode, the upper limits on the neutrino fluence with E-2 spectrum and equal fluence in all flavors were calculated. They are between 1 and 3 GV divided by square centimeter. That's all. Thank you for your attention.